morning friends, I welcome you all in this session. As you are aware, in couple of last few sessions we have discussed about probability and probability distributions. We have seen in probability distribution basically two types of distributions, discrete and continuous. In discrete we have seen binomial, Poisson. In continuous distribution we have seen normal, we have seen uniform, and we have seen exponential distribution. In today's session I would like to take up couple of questions related to probability distributions, and these questions will make your fundamentals clearer. So, let us look at first question, and these are different statements and you have to identify whether these statements are true or false. So, the first one is the expected value of an experiment is obtained by computing the arithmetic average value over possible outcomes of experiment. So, there is something called expected value, which is nothing but a weighted mean. So, this is not arithmetic mean, right. So, this statement is false. Now, if you look at second statement, the value of z for some point x lying in normal distribution is the area between x and the mean of the distribution. Is it like that? What is z? Z is standardized normal distribution, right. And how do we calculate z? Z was is equal to x minus mu divided by sigma, is not it? So, what about second statement? Is that true or false? It is again false, right, because z is equal to this, right. Now, let us look at statement number 3. The right and left tails of normal distribution extend indefinitely, never touching the horizontal axis. Is that true? We have seen several characteristics of normal distribution, and one of them was that the normal distribution, this never touches horizontal axis, right. So, this statement is true. Okay. The next one is for a binomial distribution, the mean always lies between mode and, for normal distribution the mean always lies between mode and median. Is it true? What are the characteristics of normal distribution? Let us say one of them is this, is not it, third one, and there are several other characteristics. For example, it is a bell shaped curve, it is symmetric curve, is not it, and mean, mode and median are at the same point, right. So, mean does not lie between mode and median. So, this is false, right. Statement number 4 is false. Let us look at statement number 5th. All but about 3/10 of 1% of the area in normal distribution lies within 3 standard deviation from the mean. So, what is this? Let me draw a curve for this question. So, if you look at this, you have got, this is your normal distribution, for example, right. So, you have got 1 sigma limit, 2 sigma limits and 3 sigma limits, right. So, within 3 sigma, what is the area under the curve? It is 99.7, is not it. So, all but 3/10 of 1%, what is that value? It is 0.3, right. 3/10 is 3 by 10 is 0.3, is not it. So, 99.7 plus 0.3, it becomes 100%, right. So, this statement is true, right. Statement number 5 is true. Let us look at the next one. Developing a conditional loss table is cumbersome when there are many possible actions and outcomes, because the loss resulting from every action, since this is on expected value and we did not discuss much on expected value. So, you can skip this for the time being, right. Question number 6. Okay. Let us look at the next one. The area under the curve of a normal distribution between mean and a 0.1.8 standard deviation above the mean is greater than for a distribution having mean this than it is for the distribution having mean 0. So, there are two distributions, one has got mean 100, the other one has got mean 0, and if there is a point which is 1.8 standard deviation above the mean, would that be greater than for this mean? Correct or incorrect? Question number 7 is actually a false statement, it is not a correct statement. Okay. Now, look at the next one, 8th one. The normal distribution may be used to approximate the binomial distribution when the number of trials n is greater than or equal to 60. Is that correct? We have seen that we can always use normal distribution for binomial distribution when the number of trials n is greater than or equal to 60. Is that correct? No, this is not a correct statement, because it is NP and NQ both have to be greater than or equal to 5, right. So, statement number 8 is false. So, this is false, right. Statement number 8 is false. Now, let me tell you one more thing here. We can approximate binomial distribution as a Poisson distribution, or in other words we can use Poisson distribution instead of binomial distribution if n is greater than or equal to 20, right. So, had it been 20 over here and had it been Poisson distribution here, it would this statement would have become true, right, but right now this one is false. Let us look at the next one. The two types of losses we considered in solving an inventory stocking problem are opportunity losses. In fact, this is again a question on expected value, so we can skip it, but this statement is false, because in expected value we always consider two types of losses, that is opportunity loss and obsolescence loss, right. So, this statement is false, but you can skip for the time being. Let us look at next question. When the probability of success in Bernoulli process is 50% or p is equal to 0.5, its binomial distribution is symmetrical. Is it correct? Yes, this statement is true, right, because if it is 0.5 then it is symmetric, if it is less than 0.5 or more than 0.5 then it becomes asymmetric. So, for statement number 10 this is true, right. Let us look at the next one. A frequency distribution lists observed frequencies for an experiment that has already been performed. A probability distribution lists outcomes that could result if the experiment were performed. Is correct or incorrect? It is true or false? This statement is true. Okay. So, frequency distribution is lists observed frequencies for an experiment that has already been performed, while a probability distribution lists outcomes, right. Let us look at the next one. The value of random variable will take on can usually be predicted in advance of a particular occurrence. Is it possible? Can you predict the random variable value? No, this is false, right. Now, let us look at the next one, statement number 13. Once the value of P has been decided for Bernoulli process, the value of Q is calculated 1 minus P. Is it true? Yes, this is 100% true, right, because P is known, you can calculate Q. If Q is known, you can calculate P, right, because P plus Q is equal to 1. Let us look at the next one. The expected number of arrivals in an office is calculated as 5 per hour. One can be reasonably confident that 5 people will arrive within the next 1 hour or within next hour. Is it true? So, you know from past data that the 5 people arrive at office in an hour's time. So, would you say that in next 1 hour's time 5 people will arrive as well? No, this is false, right. 14 number statement is false. Let us look at the next one. The binomial distribution is not really necessary because its value can always be approximated by another distribution. We have seen in one of the sessions that you can use Poisson distribution instead of binomial distribution. You can use even normal distribution instead of binomial distribution. So, can we say that it is not really necessary? No, it is necessary because we can approximate binomial distribution as Poisson and as normal distribution under certain conditions, right, not always. So, this statement is false. Okay. Let us look at the next one. The height of adult humans can be described by a Poisson distribution. Is it possible? We have seen the characteristics of Poisson distribution and binomial distribution, normal distribution. So, what do you think? Is it possible the height of adult humans can be described by Poisson distribution? No, not by Poisson, but normal distribution. Okay. So, this statement is false, 16 number is false. Let us look at the next one. Any action that minimizes expected loss will also minimize expected gain. Though again this is a question on expected value, we can skip this, but this statement is false because when you maximize when you minimize losses, your gains will automatically increase, right. So, both cannot be minimized, right. So, minimize expected losses will also maximize the expected gains, right. If let us say maximizes expected losses will minimize expected gains. So, had it been like this, maximize, any action that maximizes expected losses will also minimize expected gain. In that case it would have been a true statement, right, but right now this one is false, right. Let us look at the next one. After 20 trials of an experiment, a correctly shaped distribution curve is created. Is it possible? Just by having 20 trials you can have a correctly shaped distribution? No, it is not possible, this is false, right, is not it. So, you need to have a large number of trials, right. Let us look at the next one. An example of an opportunity loss could be loss of sales due to the excess age of fruit on grocery shelf. In fact, this again a question on expected value, but let me tell you what happens in when we calculate a expected value of a given question. Then generally we have got two types of losses, either opportunity loss or obsolescence loss. Now, opportunity loss is basically a loss when there is a demand of an item and you do not keep stock of that item. So, that is kind of opportunity loss. Now, obsolescence loss is a loss wherein you have the item, but you are not able to sell it. So, so this is a case of obsolescence loss, not the opportunity loss. So, this is false. Question number 19 is false, right. A distribution where the mean and median have different values can never be a normal distribution. Is it? Yes, it is correct. A distribution where mean and median have different values can never be a normal distribution. Yes, it is correct, right. So, point number 20 is correct. Let us look at the next one. The mean of binomial distribution is given by NP. Yes, correct or not correct? Yes, it is correct. So, mu is equal to NP, right. Okay. What about next one? So, 21st is true. The expected daily profit of Lemond Stand is $13.45, then tomorrow's profit will be this much, tomorrow's profit will be less than this much, more than this much, or tomorrow's loss will be this much, or none of the above. So, if the expected daily profit of lemonade stand is 13.45, so what would be the tomorrow's profit or tomorrow's loss? No, you cannot identify, right. So, this is none of the above. So, E is the right answer for question number 22nd. Let us look at next question, 23rd. For a given binomial distribution with n fixed, p is less than 0.05, the Poisson distribution will provide a good approximation. The Poisson distribution will provide a bad approximation. The binomial distribution will be skewed left or it will be skewed right, or it will be symmetric. Let me tell you that the binomial distribution would be symmetric when p is equal to 0.5, is not it, but it is less than 0.5. So, what would be the answer? It would be right skewed. It means it would be like this. Okay. So, for p less than 0.5 right skewed, and p more than 0.5 would be left skewed, right. So, just remember these three. In case of it is 50%, it would be symmetric, less than 50%, it would be right skewed, otherwise left skewed. Now, suppose we have a Poisson distribution with lambda is equal to 2, then the probability of having exactly 10 occurrences is what? It is 2 to the power minus 10 e to the power 10 factorial 10, 2 to the power 10 e to the power minus 10 factorial 2, 10 to the power 2 e to the power minus 10 factorial 10, 2 to the power 10 e to the power minus 2 factorial 10, which is correct. In fact, you need to remember formula for Poisson distribution, right. So, this lambda to the power x e to the power minus lambda, this is the formula, right, for Poisson distribution. So, we know that lambda is equal to 2, right. So, 2 to the power 10, so 2 to the power 10, right, and this is the right one, right. So, this is quite a simple question because you know this formula, right. Now, look at the next one. Which of the following is a characteristics of the probability distribution for any random variable? which of the following is a characteristics of probability distribution for any random variable. A probability is provided for every possible value. The sum of all probabilities is 1. No given probability occurs more than once. All of this A and B, but not C. What do you think? Which of the following is the characteristics of probability distribution for a given random variable? So, a probability is provided for every possible value. Yes, we provide probability, right. So, this is correct. The sum has to be 1, this is also correct. No given probability occurs more than 1, this incorrect, right. So, D cannot be the answer because C is incorrect. So, E is the right answer. A and B are correct, but C is incorrect, right. So, A and B are correct, C is incorrect. Okay. Let us look at the next one. Which of the following could never be described by a binomial distribution? The number of defective widgets produced by an assembly process, the amount of water used daily by a single household, the number of people in your class who can answer this question correctly. All these could always be described by a binomial distribution. Is it possible? Can we describe all these 3 points by binomial distribution? No, we can describe the first part and third part, not the second part, right. So, let us move on to next one. If P is equal to 0.4 for a particular Bernoulli process, the calculation this gives the probability of getting what? So, NCR is equal to what? What is the formula? Factorial n minus r, this factorial r, right, p to the power right. So, NCR, number of trials and number of successes, right. So, what is this? If P is equal to 0.4, so P is 0.4, R is 3, right, Q is 0.6, N minus R is 6, right. So, what is that value? It is exactly 3 success in 7 trials or 4 success in 7 trials. 3 or more successes in 7 trials, 4 or more successes in 7 trials, none of this. Which one is correct? NCR, number of successes and number of trials. So, for this question the answer A is correct, 3 successes in 7 trials, right. So, here N is 7, right. So, these are trials and R are successes, right. So, this is number of successes, number of trials. For binomial distribution with P is equal to 0.2, a distribution with N is equal to this would more closely approximate the normal distribution than 1 for N is equal to. So, the difference between these two is here sample size is 2000, here it is let us say N is 2000, N is 50. So, which one would be more closely approximate the normal distribution? You see, when N is higher, than that would approximate the normal distribution closely, right. So, A is correct for question number 28, right. A is correct. What about this second part, no matter what the value of n, the distribution is skewed to right. We have seen in one of the questions in previous slide, where we have seen that when p is less than 0.5, the distribution is rightly skewed, right. So, whatever is the value of n, the distribution would be skewed to right. So, this is also correct. Okay. The graph of this distribution with p equal to this and n is equal to 100 would be exactly reverse the graph for binomial distribution with n is equal to this and p is equal to 0.8. Yes, this is also correct. So, the answer to this question is D, right. So, A, B and C, all these are correct. Now, let us look at the next question. Which of the following is necessary condition for use of Poisson distribution? So, probability of one arrival per second is constant, yes, we know this. The number of arrivals in any 1 second interval is independent of arrivals, yes, this is also true. The probability of 2 or more arrivals in same second is 0, yes, it is not 0, but it is very small value. So, but we take it equal to 0. So, all of these, right. So, the answer to question number 29th is all of this. Let us look at the next one. In what case would the Poisson distribution be good approximation of binomial? In what case Poisson distribution is good approximation of binomial? So, n has to be more than or equal to 20 and p has to be less than or equal to 0.05, is not it? So, when we say this is 0.05, it means q has to be more than 0.95, is not it? So, n has to be more than 20 and q more than 0.98. So, this is the correct answer. Let us look at next one. For a normal curve with mean this and standard deviation this, how much area will be found under the curve to right of the value? 55. So, it is 1, 0.68, 0.5, 0.38 and so this is the answer to question number is 0.5. For a normal curve with mean this, how much area will be found under the curve to the right of the value 55? It is 50%, right. So, this is mean 55, this standard deviation 10. So, this is 50%, this is 50%, right. Suppose you are using a normal distribution to approximate binomial distribution, normal distribution which is a continuous distribution to approximate a binomial distribution which is a discrete distribution with mean and standard deviation equal to 5 and 2 respectively, and wish to determine the probability of getting more than 7 successes. From the normal table you would determine the probability of that z is greater than. So, you can solve this question and the answer would be 1.25. Okay. For a normal curve with mean equal to this and standard deviation equal to 35, what proportion of the area under curve will be between 40 and 82? So, this is actually mean is 120, we have to find out area between 40, let us say this is 40 and this is 82, right. So, we are interested in this area. So, what you should do? Calculate z values. So, x minus mu is 80 minus 120 divided by 35, you will get some z value, that would be let us say minus 40 by 35, you will get some z value. So, that would be the area from here to here and z is equal to 40 minus 120 divided by 35. So, minus 80 by 35, you will get some another value of z. So, this now you know the area from here to here from table, you will also know area from here to here, right, and you know this area is 50%, right. So, when you do the calculation, this would be the answer for this question, right. Which of the following normal curves look most like the curve when mu is equal to 10 and sigma is equal to 5. So, mu is equal to 10 standard deviation 10, mu 20 standard deviation 10, mu 20 standard deviation 5. So, the answer would be this, because only this value will change, instead of this will be 5, is not it. So, instead of 10 you just write 20, right. So, the answer is C. Let us look at the next one. A binomial distribution may be approximated by Poisson distribution if n is large and p is small, right. N is small, p is, which of the a binomial distribution may be approximated by Poisson distribution when n is large and p is small. Is that option is here? No, that option is not there. So, D is the correct one. So, this is the last slide, last but one slide. The standard deviation of binomial distribution depends on probability of success, probability of failures and number of trials. Yes, on all these three. The weighted average outcome of an experiment is referred as expected value. The distribution that deals only in success and failures is referred to as binomial distribution. It is usually used to describe a Bernoulli process, right. When approximating a binomial distribution by normal distribution, a continuity correction factor, there is something called a continuity correction factor. This is the last slide. The mean of the binomial distribution is mu, can be calculated as, the mean of binomial distribution can be calculated as NP. Once n and p are known, the standard deviation is calculated as NPQ, right, is not it. So, this is the answer for this question. Root NPQ is the standard deviation of binomial distribution. For a Poisson distribution, the symbol that represents the mean number of occurrence per interval is known as lambda, is not it. A list of the probabilities of outcomes that could result if an experiment were performed is called, a list of probabilities of outcomes, it is called probability distribution, right, probability distribution. The two parameters that are necessary to describe a normal distributions are mean and standard deviation, right, this mean and standard deviation. A variable is variable that assumes different values according to the results of an experiment, a random variable. Distribution can take only a limited value, which can be so discrete distribution and while continuous distribution, right. So, with this we come to the end of this particular session. Today we have seen several questions which would have made our your fundamentals clearer related to probability and probability distribution. Thank you very much.